So first of all, can anyone volunteer to subscribe today? Or
I can scribe.
okay, thank you. Oh, and Todd is here. Awesome. Okay. Cool. One thing that I wanted to talk to, like last time around, we talked about potentially running a face-to-face during May. Meeting Philippe earlier this week, he reminded me that we should notify people 8 weeks in advance of any face-to-face happening. And otherwise, there were various conflicts with potential dates we had in mind for May. So this is probably going to happen during the month of June. I will send a call to the list later today saying that we don't yet have a fixed date, though. So, yeah, we have some potential dates, but once the actual dates will become clear, I will let the group know as soon as I can. Um, And otherwise, regarding dates for the next call, so from my perspective, Thursday, 2 weeks from now, so the regular schedule works. Does that work for everyone else?
So we're back on for Thursdays then?
Sorry, I didn't hear you.
We're back on for Thursdays then?
I think so. The only reason we were on Fridays is because of travel.
So which date again?
So let me check the actual date. So it's the April 25th. And same time, so 11 a.m. PST or PT.
25th. So there is a web components face to face happening that day, so won't be able to.
Oh, okay. And if we move that around during that week, will that be easier for you?
So I think I'm traveling 24th, 5th, 6th because of that face to face on 25th and 26th.
Okay.
So even earlier in the week, another week.
Um, so from my perspective, the 22nd can work.
Okay.
There's a holiday here on the 22nd.
Oh,
Yeah, East
Oh.
birthday. Yeah.
for me as well, I guess. So it won't work. Yeah. Um,
May 2nd.
I'm traveling during that week. But maybe no, I will.
23rd Tuesday.
23rd Tuesday works for me, but Todd had a
Thank you,
conflict on
Tuesdays.
Tuesdays. Yes. Is that a full day conflict, or if we move the hours around, will that help?
I could do 9 a.m. Pacific.
Works for me if it works for Ryosuke. Will a 9 a.m. work?
Sure. We're Tuesday,
Tuesday the 23rd.
Yeah.
23rd at 9 a.m.
Yeah.
And Will and Marcus.
We think we can do that here. Okay, we can. Are we on here? We're on.
Oh yeah, okay.
Yeah.
Yeah, it works for me. Works for us.
Okay. Okay, so let's do that. 'Cause
You have for the face-to-face meeting, I see in June, the 27th and 28th of June, there is a workshop on web games in Redmond, hosted by Microsoft. So I don't know if anyone here is interested in attending it, but if they are, organizing it around this workshop might be also one solution for the face-to-face meeting.
Okay. Yeah, that's
Just giving you more data points.
yeah, I will try to collect all the data points. I know that there are some other folks with some conflicts around June, so
Okay.
we're trying to figure out a date that works for most, if not all, people, and in which we can actually find a venue. So, yeah, I'll let the group know as soon as we have conclusion on that front. Okay, and with that part out of the way, Nicholas, do you want to talk about largest contentful paint?
Sure. I'll present. So I want to talk about largest contentful paint, or LCP. It's a metric we've been investing a lot of resources into because we think it's a very good metric to measure page load, and it's a big improvement over first contentful paint. So the objective of this metric is to measure how long the main content of a website takes to be painted in the screen. So in the example image over there, we could think of two components as being possibly main content, either the logo or the search bar. So we restrict ourselves to image content and text content. As I've explained before, this is similar to element timing in terms of the scope of the content we're considering. Am I?
You're good.
Do we have echo?
No.
Okay. So we have images, including background images. And for those, we take the timestamp of the first paint that occurs after the image has loaded.
Sorry, I think somebody from Discovery District, CATOR111, should mute. I think that's the word I was coming from.
Muted.
Okay. And we also consider text. However, text notes can be very because text notes are affected by styling. Then we consider groups of text instead of just the text note itself. We're still trying to figure out the best way to group nodes of text into cohesive groups that will be the ones taken into account by the algorithm. But the idea is that we will have groups of text, and for those we consider the first paint, which is the first paint without web fonts loaded, but the first paint, basically all of the text nodes have to have painted at least once. So in the images there's an example of a important image, the logo there, and on the right there's an example of the largest text. So the main content is determined. Right now we're using the size. So for images, the size is the visual size, basically the amount of space it occupies on the screen. However, we have heuristic to reduce the size if the intrinsic image, if the intrinsic size of the image is smaller. So for example, if you have a image that is tiny, but you put it as a background image, say, then it will occupy a lot of the space in the viewport, but it's not as contentful, right? So we capture that by using the clipped intrinsic size. For text, last time we got feedback that the text size can be hard to calculate. So for now, we're just saying the best estimate from the user agent for the smallest rect containing all the text nodes. Maybe we will need to be more explicit there about what that means. So we'll need to see, but that's what we have for now. And for the LCP metric, we use the latest candidate found. So as long as the LCP algorithm is running, if you find something that is bigger, then you use that instead. So in this film strip example, LCP will first look at the text, which is the title in this case of the news article, and that will be the first LCP candidate. But afterwards, an image that is larger than that portion of text is loaded, so LCP will be updated to the timestamp corresponding to that image. Now, we don't want to run LCP forever. We have two terminating conditions for when the algorithm that computes LCP is terminated. So the two conditions are first, input. So, for example, if you scroll, if you click, things like that, that would terminate the LCP computation because user input can do all sorts of changes to the DOM, which means we can't really properly compare the timestamp of the newly introduced elements with the ones that were initially in the website before the user input. And the second condition is if there's no user input before the page unload, then, well, obviously that's a terminating condition. Oh, I should mention that a page unload can introduce some abort bias. So for example, in this strip, if the user clicked unintentionally on the web page or decides it's not interesting for them and they just click back before the image is rendered, then the LCP will be the text that is rendered before the image. So we do have some heuristics to help us actually capture where we consider the main content of a website. One example is splash screens. So in this example, the Twitter logo shows up as the website is loading before the actual loaded website shows up. And the Twitter logo can be big or can be small, but in any case, to solve this problem, we ignore elements that are removed. So if you're still running the LCP algorithm and an element is removed, then that element cannot be the most important element. So in this case, the logo will not be considered because it is removed once the page loads. And then we'll have the highlighted text be the largest contentful element. Now I'm gonna just go over some examples. Basically, the idea is to a little bit of illustration of how different this can be from FCP. So in this example, by 5 and a bit seconds, there's already a bunch of the website loaded. But it's only until after 13 seconds that the largest image actually finishes rendering after being loaded. So the LCP there will be much different. This is a case where it's also unclear if the image is actually the LCP. For example, if you look at the title, that title seems to be like a cohesive group of text. So this is probably a good argument for having a good heuristic to group text nodes. But in this film strip, we did not have any such heuristic, so that's why you can see that the two text nodes there are considered different. And so the text size is much smaller than the image size. This is another example. So again, lots of things happen before the main content is actually visible. In particular, the image on the bottom takes a long time to be displayed. Well, actually both, because that's already 23 seconds. But in this case, there are two elements that are pretty big. So the image below wins by a little bit, and thus the LCP is larger because the second image takes longer to render. This is another example. Similarly, there's two large images, but in this case, the top one wins. And in this case, it's only until like 33 seconds that it's fully loaded. It's unclear if we should consider the website to not be usable before that, but you can see by 10 seconds, only a part of it was visible. And FCP was even before 6 seconds, so that's a pretty big difference. And yeah, another example. There's also a big image. Many of these examples are from mobile websites. Most mobile websites have like a large image in the page load, so most of these will be image-based LCPs. On desktop, I think it will be a bit more varied, maybe, because some websites don't have such large images on desktop, and they do have maybe a little more of text at the initial page display. But for mobile, I think image LCP will be very dominant. Another example, in this example, this is also kind of slow website, but there is a lot of text before an image first renders. So another example for if you aborted before the image loaded, or if you clicked on one of the text links, then your LCP will actually be the text, the largest text. And the last example, this one is kind of a tricky example. It's not super clear to me if the text is the most important or the image in the background is the most important. So our heuristic for, right now we have a heuristic for ignoring background images. We ignore ones that are background of the body only. Of course, we don't include things like background color. But if you have a background image of the body, then we don't count it. In this case, however, the background image is background in a diff, so it will be counted as the largest. So the largest image will be like 29 seconds, which is quite different from the largest text. Text usually first renders much faster. Oh, sorry, I thought that was the final. Yet another example. Okay, I won't go through this one. So now that we have some examples of why this metric is important as a measure of page load, I'd like to discuss a little bit how we could, as the WebPerf working group, how we could expose an API for LCP.
Wait, I think it's unclear to me why this is important metric.
Well, basically, it measures, it attempts to measure when the content that the user cares about is rendered on the screen. And
so we've gotten a lot of feedback from web developers that first contentful paint is not super useful because it fires way too early. And I think the ideal solution there is web developers should just be using element timing and annotating the elements they care about. And that's going to be strictly more useful than largest contentful paint. But we cannot count on all web developers taking the time to annotate the attributes that they care about. And so having some metric that gives developers a better sense than first contentful paint about when things are visually ready, that RUM analytics providers can just surface for free all the time without developers having to manually annotate, we think has a fair bit of value.
yeah, so technically you could measure much more with element timing, that's true. This is more meant for analytics providers because they are not able to annotate the important elements. So without that, element timing is not as good. And
what I don't quite understand is so this is almost completely heuristics based, and I have a hard time grasping the idea that the people who are like making these websites who didn't take the time to add that element timing is somehow interested in analyzing this data. Like what?
So there are, like, there's a large set of heuristics here, but this is not heuristics based. At the, like, if you distill what we're trying to do here, we're trying to use the size of the element as a proxy to its meaningfulness for the page and for the design, because typically web developers and designers would put larger elements for things that are meaningful for the user. And so
that is precisely what heuristic is, right? I mean, that's like a textbook definition of heuristics.
That you could call it an assumption. It's not a heuristic. But yeah. But we have a bunch of heuristics that are we have a bunch of heuristics related to what that size is when it comes to text, and whether or not groups of text should be placed together if they were painted at the same time, or whether or not we should or shouldn't include background images. And we can discuss those heuristics, but at the end of the day, what we're trying to do here is somehow use the element size as a proxy to importance to the user, because it is something that the user is likely to see, and it's likely to be something that is meaningful for them and impacting their use of their site. And
I think his question wasn't what are we trying to do, but his question was, are people asking for this ability to measure something like this? Is that accurate, Ryosuke?
Well, yeah. So the question is, one, are they doing that, and then like, are they actually going to use this sort of quasi-metric?
Okay.
well, like Tim said, like FCP is widely used, and there are lots of complaints about it. So I don't think there's a doubt that there's a need for an API like this.
And I would agree with that. I would say what we don't necessarily have data on is that this particular metric will fill that gap.
Right.
And we certainly, need to gather additional data to prove that this fills that need.
So more concretely, the reason I say that is, for example, like Safari, like, or more broadly, WebKit does not even paint until such times it reaches that we think the majority of web pages painted, right? So like, for us, the first contextual painting is exactly what the website should be measuring, because that's literally the very first paint we ever do.
That's probably not true, for example, for if the web page paints a splash screen before it's loaded. Safari will probably paint it, right?
But how does this metric not apply there?
Because the splash screen is removed, right?
Yeah, so we have that heuristic around elements getting removed not being counted, but I think it's an interesting point that Safari already has an existing set of heuristics which are basically designed to accomplish the same goal. And we have not really thought about how this metric should behave in Safari. So maybe what we should do is grab some film strips from Safari and at least eyeball how we think our metric would behave.
Right. I mean, so in Safari, in many cases, we don't even like play white pages, right? Like we'll stay, like a user will continue to see the previous page, and then suddenly entire page is painted. That's what like our behavior. So like this, it is getting to the point where like things are getting very like implementation specific in terms of when things are getting painted, right? I mean, I can see this behavior this API may be useful in Chrome, but it's hard to see why websites want this and the first contextual painting always in Safari. Like I just cannot foresee a reason why this will be way more useful.
So
Hey, go ahead, Todd.
Oh, I was sorry. We have a lot of websites here at Microsoft that are built in React or other frameworks. And a lot of those have, let's say, 3 to 5 phases of rendering before they reach a point at which they've hit this larger, they might have, let's say, 5 stages of rendering, and it's about the 4th stage where it becomes kind of user usable. And if I understand correctly, the part of the intent of this API is to attempt to cover some of those scenarios as well. Is that correct, Tim?
Yeah, that matches my understanding. I think, Ryosuke, do you think if we can grab some film strips from popular websites from Safari and then hand annotate how we think this metric would behave and come up with some examples? I mean, hopefully we'll most likely see some examples where Safari waits until exactly large contentful paint, but we'll probably also see some examples where it doesn't, and we can kind of talk through some of those together at some point. Would that be useful?
Right, so that would be useful, but in those cases, though, we would consider those as just simply bugs in the browser.
So your ideal experience would be to wait until everything is painted and static, even if that paint happens in multiple
Yeah, that doesn't sound like a good user experience.
Right, I mean, we in fact have heuristics to avoid painting in a case we don't think things are ready, right? So it's
not necessarily a bad model. I think it hasn't been demonstrated that one is better than the other, as in that users are more satisfied to get everything at once or to get things as early as possible and have things load progressively for whole web pages. At least I'm not aware of any research that's proved this without a doubt. So something else I want to ask is, you say that there's a bunch of exceptions, including when there's user interaction, especially scrolling. Have you collected any data about what percentage of that metric would be discarded because of scrolling? Because in the examples I see, like 23 seconds, it's very unlikely that the user will be staring at their screen for 23 seconds and not attempt to scroll anything.
Yeah, so I'm not saying the metric will be discarded when the user scrolls. I'm saying the computation will stop when the user scrolls, because then other elements will show up. And if you just take the rendering timestamp of those new elements that were not initially in the viewport, and that will just inflate the metric, right? But if you scroll, then you still have a LCP value for the elements that were rendered before you scrolled.
The worry I see here is that depending on types of user behaviors, you'll end up comparing apples and oranges. Because if you consider users that like scrolling right away, then you're going to be measuring an element that's completely different than users that just wait a bit longer for bigger things to appear. And then when you're trying to make medians over a lot of run collected data, then I don't know. It's like it seems like you're collecting a lot of different things. As in, that metric makes sense in the context of that page load, but as soon as you aggregate that over a lot of data, which is probably what analytics providers will want to do, then it becomes a bit strange because you're aggregating things that are not the same experience, essentially.
My hope there is that if you're looking at, say, the 90th percentile, you won't have 90% of your users interacting early enough that it causes you to discard data. But certainly we need to do more research there.
Yeah, and also you could probably discard these cases based on the timestamp itself and based on further information we could provide. Like we're providing this kind of information, like intersection rect for element timing, that would let you kind of have an idea. Oh, this is probably a very small element. This probably was caused by the user aborting the website too early.
So, given the design of this feature, do you see only the rects being what you can surface, or would there be any kind of DOM attribution?
So for element timing right now, we have the rects. We have, for images, we have the intrinsic size of the image, and we have its URL as reported by resource timing, so the requested URL. We have the element ID, but obviously that won't always be there. And we have, well, I guess the element timing attribute, but that's not very helpful for if you're not annotating the website, of course. But yeah, it's an interesting question. How much attribution we need for it to be useful.
Yeah, and we could certainly add more of that kind of attribution to things like first contentful paint and first paint in a way that's consistent with element timing, theoretically at least. Ryusuke, I think one thing that is different about this metrics approach versus what Safari does is with the metric, we're identifying retroactively. So we say, we saw something that the page may be meaningfully painted, but we're not confident yet. And then we can wait and see something larger and say, okay, that previous paint was not the meaningful content. Now we see the meaningful content. Whereas Safari can't do that kind of retroactive thing, which I think means that we will see a non-trivial difference no matter what in the behavior here. I don't know if it's big enough to say that the metric is useful, but does that make sense?
So our heuristic is that we actually paint and then decide what changed and then use the metric, right? So like, we just don't show it to the user.
But so if we see an image that takes up a quarter of the viewport, you might say that looks important. We would say that might be important, and then we wait, and then we see an image that takes up 50% of the viewport, and we say, that's what was important. Whereas Safari can't afterwards decide, that previous image wasn't important anymore because it will have already painted.
Sure. Well, but hang on. My main point is not so much the specifically Safari behavior, but it was just an example. What I'm pointing out is that this thing seems to be getting very implementation specific as to how, like let me put it this way, right? Like for this thing to be very useful for web developers, we want to be like a metric that would help in all browsers, right? Like we don't want, like just because if it's particular browser right now, it doesn't mean it would be a good metric 10 years, right? If they want to make sure this thing is useful, like 10, 15 years from now. So from that perspective, I'm a bit concerned that this seems to be very much like tailored towards what the browser is doing today. Like, I agree with the general idea that there's probably some content on the page that is important for the page build, right? And we want to measure the, when those things are painted, right? That seems like a great use case. What I'm questioning is that coming up with some heuristic today would adequately address such a thing, like, long way into the future. It's just,
So my in theory, in a perfect world, we would just be looking at the pixels hitting the display because that's what the user sees. And we would be able to come up with some model for when content is meaningfully painted just based on the pixels hitting the screen. And then I think we would completely avoid that problem. It doesn't depend on implementation whatsoever. We're just kind of trying to model what the user's brain is doing. But I think that approach is going to end up being horrendously complicated. And so we want to find something that loosely models user experience without being crazy. So for
example, right? Like, let's think about the editor, right? Like, let's say you're writing an editor. right? Like, and then you first show the splash screen, right, with a giant image saying we're loading. You go to the main page. There's no image, right? There's no text because this is the editor, so it's basically blank, right? Because the main part of this editor is the user will type. So there's a toolbar and an empty space. How does this metric work in that?
Well, I mean, presumably the text editor will have an element that is gigantic and will be where you can edit, so it would capture that.
Only if there's text or image there, though, right?
It will probably have an image attached to the, unless it's like a white editor. In that case, they probably don't need performance metrics if it's such a simple website, but I don't think that.
You will also still have some text on the page. Like, presumably the page will not be a single element that is completely white. And if it is, we can then maybe add some clause to the heuristic saying that if a page is a single element, this, like, we could maybe tackle that. The thing that I don't understand about, like, if I understand you correctly, Ryosuke, your claim is that for the current implementation of Safari, this metric and the current first contentful paint will be very close to one another?
I think so. I mean, this is kind of similar to some sort of heuristics we have to decide when to do the paint, like at least show the painting.
Okay, but it will still show. So, if I understand you correctly, it will still show this metric more or less at the same time as Chrome will show that metric. It's only that FCP is significantly delayed in Safari today versus Chrome today.
Well, you can describe it that way too, yeah. Right.
So, I think that as long as we're not, or is what you're saying is that in Safari this metric will kick off earlier because you are performing some sort of a fake paint but not actually painting it to screen.
I don't think it will fire earlier, right? I mean, I think it is true that because we don't paint until the entire page is fully loaded. We'll probably paint it slightly early. I'm sure there are cases where this will fire after we have painted, right? I think, yeah.
So framing this a completely different way. There is developer demand for some method of knowing when your page is painted meaningfully that does not require manual annotation. This feels like one reasonable way we can meet much of that demand. It's certainly not perfect. There are some heuristics. Do you have any ideas on kind of alternative approaches that we could take?
Have you considered last contentful paint, which seems like a much easier heuristic to extend to web developers?
Yeah, we did think about last contentful paint at one point. There are many pages that continuously update, and so it just does not function at all on those pages. And there are also many pages which, for good reason, lazy load little bits of content, and we don't want to penalize pages which do that.
I'm really about these heuristics, trying to explain to web developers on like social media sites that have no layouts, which are a lot of images exactly the same size. What is exactly the key image? Have you thought about a way to explain that to web developers?
So I think for suitably motivated engineers, the way to explain this is sometimes it doesn't work great. You should be using element timing and annotating stuff yourself. And that's kind of the fallback. If we are trying to sort of reason through what largest contentful paint means, we can basically say if there's a bunch of images that are the same size, it picks the first one or something that's rational. But I think that from my perspective, the guidance ideally is more if you start running into problems, fall back to element timing.
Yeah, and the goal here again is to be able to gather that data for the 80% who don't necessarily annotate and can't go through, that will not go through the work of annotating their markup. And those that are interested, there's element timing that is the primitive underlying this.
So I'm curious, Ryosuke, you acknowledged that the goal seems valid. Web developers do want to know about when content is meaningfully painted. Do you have any thoughts on alternative high-level approaches we could take? It feels like this will meet many of the use cases.
I mean, this idea of like measuring when the painting, finished has come up multiple times in this working group, right? Over the last 3-4 years, many times, and I think every time it comes down to we really don't have good, well-defined algorithm to determine that. I think it comes down to it, right? If somebody can come up with this great, algorithm to do that, it'd be great. But I think it just always comes down to a bunch of heuristics.
I think that. So one thing that I think is different, I think having element timing gives us a good fallback for developers who are motivated. I think that we tried first meaningful paint before was just a giant bag of heuristics. I don't remember if we ever presented that here, but I think that this is simple enough and sort of user experience focused enough. I certainly agree it's not perfect, but I don't think it would be the right move to say we can't ship this thing that provides real value to a huge number of web developers because it's not perfect.
I'm not saying it's because it's perfect. The problem is, one of the big problems with heuristics is that heuristics that might work for web-based today may not work in the future, right? And we can't just keep changing heuristics either.
So it's not just heuristics, right? I explained how the size of images is calculated, and so the reason for heuristics is to exclude some of the elements because they are like background images that are just displaying with repeated. I'm not saying this is like a black box that the browser has to invest a lot of resources into to figure out which is the main content. We're saying let's consider using the size of the element in the viewport as a proxy for how important it is, with some caveats like the background image attached to a body. Or the element that is removed to be able to exclude splash screens, right? It's not. I don't think it's accurate to describe it.
The idea of using an element that is biggest in page itself is a heuristics, right? I mean, it seems to keep saying that this is not heuristic, but it is a heuristics. I mean, we can talk about the definition of what a heuristics in the great lengths, but let's forget about the wording, right? The problem is that this is at best the proxy for the painting time the user cares about, and
Yeah. Sorry, someone typed something into the chat and I was unable to catch it and have no way to look at it now. Was that Mozilla folks, maybe? Or no?
No, that was me. I just created a little web page yesterday to actually talk about measurements. And this one shows 3 panels that load one after the other one. And I was wondering what would be the value of LCP in that case. So it's just a web page hosted on Heroku that you can hit.
So if each of those, say, has an image, a single image, which is the same size, it would be the first one.
No, the last one.
We should figure that out.
Okay, yeah, it depends. If they are the same size, then I'm not sure.
Yeah. We should figure out how tie breaks work. But I think, taking the first one is probably correct.
I guess the question is not if, I would be very uncomfortable if the result would be that this is a problem that we cannot solve, as it seems like a use case that developers continuously demand for, and it seems like
I
you
agree.
know
This is a use case we should try to solve, but I am not convinced
Well, they're asking for it, but they don't know what to ask for. And I think something that might be interesting is to see the outcome of what people do with element timing, because the people who do spend the time to annotate will surely come up with patterns and things to recommend others to look at, etc. And then maybe it'll become clearer what matters and what doesn't once that API is out and people are actually trying to make measures. But right now, it's a lot of guesswork to figure out. And in one way, you say, this is better than last minute info paint because last minute info paint doesn't work for X category of websites, but this doesn't work for another, n amount of websites where the background image will be a div or whatever. And there's always exceptions.
We did analyze examples to determine that this one is better than last contentful paint.
So also, Gilles, sorry.
Yeah.
Gilles, I wanted to say something like, for example, we sell a platform for a customer to customize their page, and they do that almost every day. And so element timing for us will not work because the customer, they add and remove components all the time. So it's their own components. So for example, these metric for us would be fantastic.
I understand. What I'm saying is that we still haven't given the chance to websites that can leverage element timing and that will discover patterns that work to inform the design of a standard like this for the other websites that cannot use it. That's what I mean. I'm playing with element timing right now. I still don't know if it's going to do the job for us and if it's going to have a better correlation to user opinion than existing metrics. I can tell you that in a couple of months. What I'm saying is that, those two things are kind of related and trying to design something that's close to user experience. And I think it's just maybe a bit early to try and figure out the universal pattern that would be the best for this sort of thing. But if this takes time, you can course as you go for sure. It's just my impression is, this is making a lot of assumptions about the user interaction model. And if it were me, I would study, for instance, how users behave. Regarding it's back to the scrolling thing I mentioned, but it could be other things. This is still bringing me memories of this old school model of, say, synthetic metrics, where you're just looking at what's above the fold, and that's not relevant anymore. People are not waiting to interact. And so it would be, if you're trying to make something future-proof, which I think was what Ryosuke was hinting at, maybe the future is that people are, if you think of performance getting better, people are going to interact more very early. And so that model is going to make that metric a lot less useful, because if your website is interactive very quickly, people are not going to stay on what's above the fold. And so you're measuring something that's become defunct in a few years. If we meet our goals and people make faster websites. In which case, you might want to think about a metric that captures also the fact that people are moving and that their initial early experience also encompasses elements that are not above the fold initially. That's more complex, but that's what I'm trying to get is that this is quite disconnected from the user experience, in my opinion.
Yeah, you could imagine some web app where page is not really fully rendered because it's still loading content, right? Think about some sort of social media like a Twitter or Facebook. Posts are still loading, but maybe user can still scroll, and then maybe that website starts loading from the content that users seems to be most interested in. And did you do any study about websites that have already adapted element timing to see if this metric would work, even if they if the metric they're tracking and then this metric would match if you ignored element timing, for example?
The total set of websites currently using element timing is very small, but we should definitely do that. We have not done that yet.
I'm wondering, Nick, Charlie, are you on the call?
Yeah, I am.
Okay. Wondering regarding the opinion, from an analytics provider's perspective.
Yeah, absolutely.
How would you
I think
consider this?
Our thoughts mirror a lot of what Julia is saying. For analytics, for a generic analytics case like ours, where we have a lot of customers, anything that can be done automatically is going to be used way more than something that we have to convince the customer to go in and instrument their site. Element timing is a great example for the customers that really want to use it, or something like user timing. You know, a very small percentage of our customers actually have, you know, specifically instrumented their pages with user timing, or will be doing it with element timing. So I really like the idea of trying to find something that, you know, heuristic based or not, gives other, you know, metrics like this, because our customers definitely are looking at paint type stuff. They're, you know, they see the first contentful paint in there, and they want something beyond there, like first meaningful paint or what have you. But obviously, there's nothing else there today automatically from the browser. So, like, I certainly like this idea in general. Like, I'm excited about it. I'm a little. I think we would have to think through a lot of the ramifications of the user input affecting the stopping of updating the metric, and we would definitely have to understand or you know, log when those interactions occurred in the page as well. So on the back end, we could, you know, we can try to figure out what sort of bucket, or you know, how to present that data in a way that where user input is actually actively affecting the metric. I think much more than any other metrics that we capture today. You know, user input generally doesn't affect nav timing, and you know, whether you're doing user timing and stuff like that.
Yep.
So I think it's definitely the step in the right direction. You know, I certainly don't understand all the browser downsides to it. So I depend on you guys figuring that out. But from an analytics point of view, like we're definitely on board for getting something like this.
So from my perspective, what I hear from folks here is one concern regarding the fact that input here has an, you know, stops gathering the metrics. So you know, that seems like this is something that may require more thought. And otherwise, when it comes to heuristics, how comfortable are folks on the group with the heuristic-based approach, which is basically, I mean, Nicholas mentioned a few heuristics, around input, removed element, heuristics around text size and whether or not text nodes that are painted together should be grouped, as well as heuristics around background images. My question to the group is, how comfortable would the group be with if we will try to distill those, like the intent behind the heuristic as part of the specification, but leave them to be user agent defined? So I don't know, for the background image one, it's true that browsers could figure out other ways in which they you know, recognize non-significant background images versus significant ones. I don't know, based on you know, if they are, you know, the level of entropy in the image or whatnot. These are not heuristics that we would probably want in the spec, but we want the intent to be something that all browsers more or less implement. Is that something that sounds reasonable to folks?
So from my perspective, I'm not thrilled about it, but I don't really see a much better alternative. Like ideally, you would want the heuristics in the website maybe. So in my ideal solution, the website would get like all the data it needs to apply its heuristics, but that's not really feasible. Like it would take up too much memory. You would track too many elements. You would maybe have, I don't know, privacy implications by exposing too much data. You would run too much code to analyze those pieces of data. So I think there's not really a way to get around having some heuristics in the browser for this. And
right. So I think
yeah,
it's probably better if let's say some analytics provider wanted to get this information like this. If there's a way for analytics provider to have the heuristics, right? Like browser provides some data, and analytics provider is the one that implements the heuristics. That's probably a better model than browser, hard coding a bunch of heuristics in the browser and hoping that it would work for next, 20, 30 years.
So I guess the idea there would be to relax the constraints for element timing to dispatch entries so that the analytics providers can do the work instead of us exposing the LCP with the work being done. Does that make sense? I don't know.
Do you mean like more things automatically from element timing, essentially?
No, less things. I mean, yes. More, implicit registration being more relaxed, right? Yes.
Yeah, or so potentially reducing the size limits of element
Actually, I had a proposal kind of like that.
I think we're basically at a time and we're getting kicked out of this room.
Oh.
Just want to say thank you, everyone, for all that feedback. I think we've got a lot to chew on and think about. Thanks very much. It's very useful.
Yeah, thanks for the presentation.
Thank you.
Thanks.
Thanks.